Hello, and I would like to help you with an algebra problem that is a mixture problem. Now this problem is actually pretty involved, so I have all the work shown for you here, and I'll point through the various parts. It says, an iodine solution is essentially a mixture of water and the element iodine. An iodine solution is described using a percentage which indicates what percent of the entire solution is iodine only. Here's your information. You have one beaker which contains an unknown amount of a 15% iodine solution, and another beaker which contains an unknown amount of a 20% iodine solution. You also have a third beaker which contains 100 milliliters of a 10% solution. You add only half of the 20% solution to the 15% solution, and the mixture becomes an 18% solution. You then add 50 milliliters of the 10% solution to the whole mixture. After this, the whole entire mixture of the 15% solution, half the 20% solution, and 50 milliliters of the 10% solution becomes a 14% solution. How much liquid in milliliters was originally in the beaker with the 20% solution? And how much liquid in milliliters was originally in the beaker with the 15% solution? Okay, so in order to deal with this problem, we have to label things carefully. First of all, let's call the amount that's in the first mixture, or the first beaker I should say, in milliliters X, and let's put that in red. We know it's 15% iodine. The amount of iodine is 0.15 as a decimal multiplied by X, which is in milliliters. The second mixture is Y, and that's 0.20, and that's times Y to get the amount of iodine. For the known third beaker, it's 100 milliliters, 10% iodine solution, multiplying them, that's 10 milliliters of iodine, that's known. The first mixture, let's go ahead and call that here in purple, which I have labeled here. By the way, you'll notice that the color coding in the knowns is kind of important to keep everything straight here. So the mixture is 18% solution, that's this 0.18. But notice that it's X plus 1/2 Y, because that's the same thing as half the second solution, which is half the 20% solution. You add those together independently. Multiplied by that 0.18, we get this equation. But that's equal to the sum of each of the components, which is 0.15x in milliliters, plus half of this amount of iodine on the second solution, that's 0.10y. So this is our first mixture. Now our next mixture, we take this mixture and we add 50 milliliters of the known solution. So there we go, plus 50. The solution ends up being 0.14, which is again 14% solution. When we multiply those, this is the equation, 0.14 times x plus 0.50y plus 50, close parenthesis, equals, that's the second mixture, these two components, solution 1 and solution 2, plus 5 milliliters of iodine, because that's 10% of this 10, it's 10% of this 100 milliliters, but then half of that, so that's going to be 5 milliliters of iodine, or you could say 10% of this 50. Okay, so these are two equations which involve both x and y, and there's two unknowns, so we call this a linear system of equations. You can solve this by elimination, substitution, or graphing. I will show the solution to this by substitution. We'll confirm it by graphing. So if we rewrite those equations that we see on the bottom of this board, so when it comes to the equations, here's what we have. We have 0.18 times x plus 0.5y equals 0.15 times x plus 0.10y. That is the concentration times the entire amount of mixture is equal to the sum of each of the components, the concentration times the amount of each component. We do the same thing for the other mixture. The other mixture is 14% solution, so that's 0.14 times x plus 0.5y, that's half the y solution, plus 50 that's the volume, the amount, equals 0.15x plus 0.10y plus 5. And then 5 here is 10% of 50. Okay, so that's the idea. Well, I'm going to suggest here we multiply by 100 to clear all outside decimal values. So we multiply this equation through by 100, this equation through by 100. I switch to black here. We have 18 because multiplied by 100 times what's in parentheses here. Then this becomes 15x, this becomes 10y. And then on the right hand side here we have 14, the same parentheses, we're using the 100 once, 15x, 10y, and 500. Okay, so these are two equations, two unknowns. This is a linear system of equations we will solve by substitution. So I think that the first equation on the left is easier to solve. If we distribute the 18 to the x and 0.5y, we have 18x plus 9y equals 15x plus 10y. Then let's try to isolate. If we subtract 9y from both sides and we subtract 15x from both sides, we have 3x equals y. But notice 3x equals y. Remember, x is what we were doing in red. So in other words, y, the amount of the second solution, is going to be 3 times whatever the amount of the first solution is, x. That's a useful thing to know. So if we can substitute for y into this equation and this equation, notice, so after substituting where the squiggly underlines are, y now becomes 3x in this equation. Then let's distribute the 14 in, and then let's distribute this 10 times 3x. So we have 14x plus, then 14 times a half is 7. Then we have 3x here, so that's going to end up being 21x in just a moment. 14 times 50 is 700. Then on the right-hand side, 15x carries down. 10 times 3x is 30x, and then 500. Well, it's a matter of solving this. So 14x plus 21x, that's 35x. 15x plus 30x is 45x. That's like terms. And then this side has 700, this side has 500. So let's subtract 35x from both sides. We have 700 equals 10x plus 500. Subtract 500 from both sides, 200 equals 10x. Divide by 10, x equals 20. Remember, that's volume in milliliters. After that, we should plug that back into here. So 3 times that, 20 milliliters. The y is 60 milliliters. So now we have the values of both x and y. The values of both the first and the second solution in terms of their volumes. Now let's see if we can confirm that via graphing. So what I have shown here is a graphic where this is the y-axis. The y-axis is going to be the axis of the second solution. And then this right here along the bottom horizontal is the x-axis. And notice that we're only in quadrant 1. Quadrant 1 is when both x and y are both positive. That's because we expect there to be real positive values for each solution. Well, it turns out that if we plot in purple this first equation, that was for the first mixture, and we plot this second equation for the second mixture by using a piece of software, the purple dotted line intersecting the orange dash line exactly intersects at 20, 60. That's x, y. That's the volume of each in milliliters. Now that's more of the software way to solve this, but that's confirmation that we did get the right answer. Thank you very much for watching High Peak Education. Please smash that like button if you enjoyed this content. Please share this content amongst your social network. And please subscribe to the channel to grow the channel. I look forward to reading your comments as well, and I will see you in the next video.